Hello, welcome to lesson 3.5, working on our equations of lines. Hopefully this is an easy one that just reviews slope-intercept form, or y equals mx plus b, and utilizes what we know about slope from our last lesson. So let's go ahead and take a look at our notes so we can start with these examples. All right. So here we go. We're a little bit more straight. Okay, there's a few things that we want to keep in mind right from the beginning. Okay, we're going to need several review equations from Algebra 1. First, and most important, is our slope formula. You can't have the equation of your line without knowing what your slope is going to be. So always make sure you know the slope first. And again, our slope formula, okay, is rise over run. So rise, moving up and down, that's your y-axis. So always have your y coordinates in the numerator. And your run, just like you're reading a graph or running forward, right to left. So that's your x coordinates. Those will be in your denominator. A formula that you can use is point-slope form. If you're given a point and given a slope, you can plug those values in to find the equation of your line. You would plug slope in for m, that's always the variable we use for slope, and the point would have coordinates x1 and y1. Okay, the x and y are your x and y that you would have in an equation. So you can go ahead and plug in or use that if you're comfortable using point-slope form. I will, as I work through our examples, just use slope-intercept form. I tend to always use slope-intercept form, and that's how you write equations of lines. They need to be in slope-intercept form. So what we want to do is make sure that we know the slope first. So m is our slope. Okay, and then b is your y-intercept. Okay, where the graph would cross the y-axis. Okay, but you are typically solving for slope first and then finding your value for b. Those are always the variables that you need to know, okay, or find a value for, and then x and y will remain in your equation. Now, sometimes at the start of your problem, okay, or at the end, you may need to put the form of the equation into standard form. Okay, if you're in standard form, you have it in the form of your x term plus your y term equal to a constant value. This is just another form of slope-intercept. So if you wanted to take standard form and convert it to slope-intercept, you would just solve for y, or get y by itself. So move ax to the other side, divide by b. Okay, so that's exactly how you would actually find slope too, is solve this equation for y, and then whatever term is in front of x, that is going to be your slope. Okay, so let's look at a couple examples here, okay, to work our way through. Okay, first, a line passes through a specific point. Okay, we know that 2, -3 needs to be on our line. So this would give us a value for an x coordinate and a y coordinate. And I know that I want my line to run perpendicular to this line here, y equals -1/6x plus 5. So currently the slope is that value in front of x, so -1/6. But we want to be perpendicular, so we want the opposite reciprocal. So we want our slope to be +6. So if I were to plug into slope-intercept form and plug in what I know, okay, I know that I have a point on my line that has to make the equation equal. So my value for y would be -3. I want my line to have a slope of 6. Okay, the x coordinate in that point was 2. And I want to solve for b, or what that y-intercept would be. If I do that, I would subtract 12 from both sides and get a value of -15 for that intercept. So So the equation of my line would be y equals 6x minus 15. It has to have a slope of 6 to run perpendicular to -1/6, and it has to cross the y-axis at -15. All right, in number 2, we want to find a line that runs parallel to y equals -3x plus 4 and passes through this point, -5, 6. So again, currently the slope of this line was -3. We want to be parallel to that, so we have to use one that's exactly equal. So our slope also has to be -3. And I have values for x and y, okay, from my point. So again, if I plug into slope-intercept form, the y-intercept is what I want to be solving for. So I have a y-coordinate of 6, a slope of -3, an x-coordinate of -5, and I can then solve for that y-intercept. We would subtract 15 from both sides to do that, and b would then equal -9. So my equation would become y equals -3x minus 9. Again, running parallel because the slopes of these two lines are exactly the same, and they have different y-intercepts, so they would be located in a different place on the graph. All right, then let's go ahead and take this a step further, okay? Just giving us an equation that's in standard form. Keep in mind, anytime you're given an equation in standard form, you can always convert it to slope-intercept to make that work. So we want to find the equation of a line that passes through 3, -4. So those would then be my values for x and y, and perpendicular to this equation. Well, first of all, solve this for y. If we were to divide both sides by 5, that would make y equals -3/5 x plus 4/5. So the slope in this case was -3/5. However, we want to run perpendicular to that. So the slope that I'm going to want to use that runs perpendicular is going to have the opposite sign. So this was negative, ours is going to be positive, and the reciprocal of 3/5 would be 5/3. Okay, now we're also going to have to deal with that fraction appropriately when we go to plug that in. So if I were to plug into slope-intercept form, okay, to solve for my y-intercept, I'd be plugging in -4 for y, my slope of 5/3, the x-coordinate of 3, or I could make that 3/1 if I was plugging that in, and then plus b. Well, what works nicely here is the 3's cancel out, so I won't have to end up working with fractions. I get -4 equals 5 plus b. So we subtract 5 from each side, and b would be equal to -9. So if I was writing an equation that runs perpendicular, that would be at y equals 5/3 x minus 9. Okay, my slopes here were opposite reciprocals, and then I plugged in the value for that y-intercept. All right, so same thing with number 5 here. The equation of this line was 3y plus 2x equals 12. So just kind of be careful with the order in which those variables were given there. That's not quite standard form. And write the equation of the line that runs parallel to this situation. Well, let's go ahead and take this equation and put it in slope-intercept form. So we still want to solve for y. So I'm going to move the 2x term to the other side. So it'll be negative 2x plus 12. And divide everything by 3. So we get y equals negative 2/3 x plus, well then 12 divided by 3 is 4. I want my slope to run parallel to this line, so we want to use this exact same slope. So the slope that will run parallel will also be negative 2/3. Now we do need to include this point, so that's going to be my value for x and y when I plug into slope-intercept form. So the value I'm plugging in for the y coordinate was 7. Slope was negative 2/3. My x coordinate was negative 6, so I'll put negative 6 over 1 just to line it up with my fraction, and then plus b. Well, here the 3 will cancel with the 6 and become a 2. So negative 2 times negative 2 would be positive 4. So I'm subtracting 4 from each side, and I get a y-intercept there of 3. Well, then the actual equation that runs parallel is going to be y equals negative 2/3 x and then plus 3. Now, just in case this is multiple choice, it's very possible that they might take the slope-intercept form and convert it back to standard form. If so, you would bring your x term to the other side, so 2/3 x plus y equal to 3, and then we'd eliminate this fraction, so we'd multiply by that denominator, or multiply everything by 3. So in standard form, this would be written as 2x plus 3y equal to 9. Make sure that value is distributed to every term. So just a possibility here. Most of the time we will ask that you solve for the equation in slope-intercept form, but if it's multiple choice, always be able to find the equation that's equivalent in standard form. Okay, just convert that form once you have your answer. Now, I want to extend this lesson just a little bit further, just to kind of help us review some concepts about horizontal and vertical lines. Okay, because we want to be able to apply it to our parallel and perpendicular situations. So in number 6, we were asked to write an equation of a line parallel to y equals 7 that contains the point negative 3, 19. Well, first of all, we need to know what kind of line y equals 7 is. Well, if you're graphing that, you would simply go to the y-axis and intersect that at 7. So if we're intersecting the y-axis at 7, it's going to create a horizontal line. So the only thing that's going to run parallel with a horizontal line is another horizontal line. So horizontal lines are always going to be in this form, y equal to a constant value. So all I need to do is look at my point and determine what that y coordinate is, because that has to be my constant value. So the equation of the line that will run parallel with this one will just be y equals 19. But again, if it's parallel, the line should be in the same form. So y equals 7 and y equals 19, which would be way up here, they would be running parallel to each other. So let's take this same scenario now, but change that. Okay, so this time we want the equation of the line that runs perpendicular to x equals negative 12, containing the point 10, negative 4. Well, keep in mind that x equals negative 12 is going to be a vertical line that crosses the x-axis at negative 12. If we want to be perpendicular to this, We then need a horizontal line. We should know from our last example, the horizontal line has to be in the form of y equal to a constant. So again, I want to analyze what that y coordinate is going to be, and my equation will become y equals -4. And again, should make sense that those are running perpendicular to each other because a horizontal line and a vertical line always intersect at 90 degrees. Think about your x and y axis. They cross at 90 degrees. Okay, so those are running perpendicular. Okay, so just a little bit of a review there with horizontal and vertical lines. Good things to note algebraically. But the main focus of this lesson is going to be to work with writing equations. So always make sure that you're actually writing an equation as your answer. Okay, most commonly we're going to write the equation of that line in slope-intercept form, or y equals mx plus b. Okay, if you're needing to find values, you always solve for slope first, then your y-intercept. All right, good luck with this assignment.